Okay, my dear friends, we finished our last video here. The classical definition of probability. Probability of A means probability of any event is equal to number of favorable events by total number of events. Today we'll discuss these things elaborately. That I told you we'll discuss all the things elaborately. So let's start. First, probability of an impossible event. Okay, probability of an impossible event. If I take one random experiment, what is the random experiment here? We are taking rolling a dice. So, what is the sample space? 1, 2, 3, 4, 5, 6. This is the sample space. Now, if I ask you, what is the probability of getting 8? So, is there any 8? No, there is no 8. So, this will be 0 by favorable number of events by total number of events. 8 is not there. So 0 by 6. So it will be 0. It will be 0. So the probability of an impossible event is 0. So P of phi equal to 0. P of phi equal to 0. I hope it's clear. Probability of an impossible event. Now we will find the probability of an sure event or certain event. Sure or certain. Certain event. What is the probability of that? So what is certain event? We discussed that if rolling a dice, is a random experiment, and then if I ask you what will happen if I roll the die, then you told in between 1 to 6 anything may happen. So that is a sure event. Surely it will happen. So probability of sure event, here I am writing, in this case sure event means anything we will get. So 6 by 6, favorable number of events 6, total number of events 6. So this is 1. This is 1. So probability of a sure event is 1. Okay, I hope it's clear what is the probability of a sure event. Now I will discuss if the probability of a certain event and sure event. I hope it's clear to all of you. But if it's not a certain event or an impossible event, then what is the probability? Look at here. Number of favorable events by total number of events in the sample space. That is the probability of an event. So number of favorable events can be more than total number of events. No. Why? Let us take an example. If I take this example, rolling a dice, random experiment. So 1, 2, 3, 4, 5, 6. So events, what is the definition of events? Events means they are subset of this set. Subset of this set. And the cardinality of the subset means the number of elements in the subset cannot be more than total number of events of this set, the cardinality of this set. Whatever you take the subset, taking that set of even numbers here, set of odd numbers from here, set of prime numbers from here, set of numbers which are less than 6, like that. You take any kinds of events, but their cardinality will not be more than the total number of events. So it's a like a fraction, vulgar fraction. So numerator is less than denominator. If numerator is less than denominator, what kind of fraction is this? If numerator is less than denominator, then we call it proper fraction. Proper fraction. Proper fraction. And another definition of proper fraction is always less than 1. Proper fraction is less than 1 and greater than 0 if it is positive. Proper fraction is greater than 0, less than 1. So that's why probability of an event is greater than or equal to 0, less than or equal to 1. When it is, I told here, less than 0, greater than 0 and less than 1, but here equal to symbol, when probability of an event is equal to 0 for impossible event, this is equal to 1 for certain event. That's why probability of an event is always more than or equal to 0 and less than or equal to 1. If it is asked to you that probability of an event E is equal to 7 by 5, is it possible? You have to say no, because numerator is more than denominator. It cannot be. Its value is more than 1. Its value is more than 1. So it cannot be the probability of any event. I hope it's clear. So let's discuss a little bit more. If it is given probability of any event B is 120%. Is it possible? It's not possible. Why? Because if you express it in terms of fraction, so it is 120 by 100. So numerator is more than denominator. So it cannot be the probability of any event. But if I give probability of B is 30%, it can be the probability 30 by 100. Numerator is less than denominator. I want to make you understand that probability of an event is always greater than equal to 0 and less than equal to 1. If we discuss about the number line here, 0, 1, minus 1, it's a number line. So the probability of any event is always lies between 0 to 1 here. It cannot be any other place. Okay. If probability of any event C is 2.5, can be? No, it cannot be. So it cannot be the probability of any event. Okay. Hope it's clear that why probability of an event is always greater than equal to 0 and less than equal to 1. Now we will learn about this one, addition property of probability. To understand this addition property of probability, first we have to go to the set. Okay, I hope you know, if A and B are two sets, then A n of A union B equal to n of A plus n of B minus n of A intersection B. I hope you know this one. This is from the set, the cardinality property. So here the probability of A union B equal to probability of A plus probability of B minus probability of A intersection B, as it replace N by P. This is called the addition property of the probability. For class 10 students, it's not required, but we should know this one. This is the addition property of the probability. Why did I teach this one? Because when now we are going to learn about the probability of complement events. So from here it will come. Okay. So now one more thing here. If two sets are disjoints, their picture is like that. If they are disjoint sets, I told when I taught the events that they are mutually exclusive events. So A intersection B means common element is phi. So probability of A intersection B will be 0, and from there we can say probability of A in union B equals to probability of A plus probability of B only. There is this is 0. So this is only if A and B are mutually exclusive events. Okay. I hope it's clear. Okay, this is for only for the mutually exclusive events. Probability of A union B equal to probability of A plus probability of B. Otherwise, probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Now, we will study the probability of complement of an event. Let us take an sample space, a random experiment, that is tossing a coin. This is a random experiment. So what is the sample space? Sample space is this one, head comma tail. I taught you that getting head, its complement event is not getting head. If A equal to this one, then A complement is this one. Getting head, its complement event is not getting head, means getting tail. So its favorable event only singleton H. Its favorable event singleton T. So H union T equal to what? H comma T. That means the sample space. So if I put instead of H A union A complement equal to S, now apply this formula. Because they are mutually exclusive events. Mutually exclusive events. So probability of A union A complement equal to probability of S. Probability of S means it's a sure event. Its probability is 1. We learned already. So probability of A plus probability of A complement is equal to 1. That means probability of A complement equal to 1 minus probability of A. That you have to remember. So probability of A complement of an event is 1 minus probability of that event. Okay, this is important. So by this, the theory portion of the probability is finished here. Okay. Now in the next class we will solve the sums of probability. How many possible I will solve there. So study hard and keep practicing. Thank you.